All right, the second lecture of week 3 is strings. So the package that we use in Tidyverse to deal with strings is string R. I asked you to read through its documentation, so make sure you glance at it at some point during this week. Just to review, strings are a sequence of multiple characters. So if you run the class function on a string, it's going to say character because a string is just composed of more than one character. So character, A, B, C, whatever, a string would be A, B, C combined. You can create a string using your quotes. So R is going to read anything in quotes as a string value. And then all string functions in this package, in string R, are going to start with str_. I'm just going to say string when I read this, but it's helpful that you know anything in this package starts with that. So you can create strings from data. To do so, you can use these different functions. String C is by far the one that I've used the most. String C is going to take any number of vectors as arguments and return a character vector. Essentially, it takes multiple different string elements and smashes them together into one. Sep equals is a really useful argument because you can tell it what do I want the separator to be between these individual elements. String glue is helpful when you are mixing fixed and variable strings. So that would be if I want a name and then a value after that name that stays the same. Anything within curly brackets is going to be treated as not part of the string, so you can just have name and then a set phrase. And string flatten, similarly, it works well if summarized because it's always going to return a single string, and again, you need to specify separators and what you want the last element to have in front of it. Don't worry, we're going to go over all of these in the script example. So you can create strings, you can also extract data from existing strings. So separate longer delim, you can split based on a delimiter, separate longer position, split based on position, separate wider delim, split columns based on the delimiter, and then you have new column names. This should feel familiar because you did see me use this in the active duty marital example when I split the pay grade and pay type column. So that was a column that had two variables essentially smashed into one, and because it was a string value, I was able to separate it based on the dash that it had between them. And then separate wider position is going to specify how many characters go in each column. This should feel familiar to you because it's the same principles as pivot wider and pivot longer from last week. Essentially, we have a column or a row and we say, hey, wait a second, this has multiple variable types in it, like pay grade and pay type, and I want to separate it out. And if it's a string value, these are the functions that you can use to do so. You can also count how many letters or individual characters there are in a string, and you can extract individual parts of a string. So let's say I want to extract just the second through fourth indices in a string. You can do that with string sub. So let's go ahead to our code for some examples here. So again, this section is going to use functions from string R. Let me go ahead and clear this out for us so we start fresh. That's just a hint, if you want to clear your environment, all you have to do is hit this broom. Same thing with your console. I usually like to start out all of these lectures with a clean slate so you can see what objects get created. So let's start with string C. String combine is how I read this in my head. Again, it's just going to combine different strings. So this is a character vector. Each of those individual strings are just, one item in the vector. And when we combine it, we see that it smashes together. This is a character vector. Let's look up string C. Again, you can always type question mark and then the function name to learn more about what it does and what its arguments are. And we can see this pop up over in our help screen. So string C combines multiple character vectors into a single character vector. Great. The argument I want to bring to your attention is sep. So separator is whatever string you want to put between input vectors. Traditionally, when we read, we have spaces between words, so we're going to do the same thing. We're going to say that the separator is space, and this is a lot more legible. So this looks much better with spaces between the words. This is a character vector versus this is a character vector. So let's create a tibble of names. A tibble is just the tidyverse version of a data frame. And so what I've done is I've created this. George, egg, Brian, Dave, NA, so I pulled in a null value, and shrimp. So let's create a new data frame based on that. I'm going to call it df good boy. Df then mutate, creating a new column called good boy, and I'm combining that name, so George, egg, etc., with this string value of space is a very good boy. That space is important because if I don't pull that in, then it's just going to be name is with no separator between. So let's look at that column. Let's look at df good boy. Here, great, George is a very good boy, egg, whatever, it went through all of the names, and then followed that up with space is a very good boy. Now notice NA. So here there's a null value in name, and so this, it just ignored it. It said, okay, there's no value there, we're not going to pull that, we're not going to assign the is a very good boy to anything. String glue is going to do something very similar. It does the same thing. Anything within these curly brackets, so this variable name, is not going to be considered part of the string. So rather than having name, comma, space, quote, space, now I just have exactly what it wants to look like. So let's do this. We're adding in a new column here. And now, great, George is the best boy, egg is the best boy, but we see NA, as opposed to treating this as a null value, string glue just pulls that in and pretends that NA is the name. So that's just something to think about depending on what you want your output to be. They do very, very similar things. And so let's try string flatten. So here I'm going to create another Tibble, and what I've done is I've just listed out some of my friends that are also getting PhDs, and I've listed out their discipline as well. So here, let's look at this data frame. Kwon Jung, Anna Julia, Sean, Josh, etc. All of their disciplines. And in fact, I want to have a space in this name, so let's try rerunning that. Great, that looks better. So for summarize, what I can do is summarize the disciplines. And what I've done is I use string flatten. I say the discipline name. I want a comma between each. And then for the very last one, I like to have comma and as when I list things out in text. So I have comma and. So let's see how that looks. We've summarized the disciplines. So there's linguistics, performance studies, psychology, and acoustics. And it spits back out linguistics, performance studies, psychology, and acoustics. So we can also extract data from strings. So I'm going to do the example of separate longer delim. Yet another Tibble. We're creating one called pet names where I've got George, Cleo, Pippin, Brian, Lemon, and Chenza. All of the individual elements are of different lengths, but they're separated by the comma. So let's look. Here we've got George, Cleo, and Pippin in one, Brian and Lemon in one, and Chenza in the other. I organize this. These are rabbits, these are fish, and this is a dog. And what I want is I want to separate anything with that comma. So what I can do is use, I'm creating a new data frame just so you can again compare the differences. String separate, or excuse me, using the same data frame, string separate, then separate longer delim. I say I want to separate the pet names, so I want to separate this columns, and I want the delimiter to be that column. So now let's look, great. Now everything within those commas is its own thing. So pet names right here. So string separate. Here we go. There we go. Okay, so last thing, let's say, let's look at letters and subsetting. So let's say I want to know how many names in the baby names data are between 15 and 20 letters. I'm going to read in the baby names data frame. You should recognize this. This is part 2 of challenge 2. And I want to filter anything between 15 and 20 letters long. This is going to be helpful for you for your upcoming challenges as well. So here I'm saying baby names, I want to filter because I want to filter based on the rows. I want anything where the string length, when the number of characters in the string is greater than or equal to 15 and it's less than or equal to 20. So then again, with these logical operators, I have to pull the name, the column name twice. I can't just go string length name greater than equal to 15 and less than or equal to 20. I have to specify what exactly. And then I have the values that I want it to select based on. So baby names, filter, I can see that there's 138 names in this new tibble, so that I know there's 138 names that are 15 to 20 letters long. So let's say, for fun, I want to know the first letter of every name and which letter is the most common. So what letter are people naming their kids with the most? What I'm doing here is I'm creating a data frame called first letter. I'm opening baby names, and then I'm mutating. I'm creating a new column called first. I'm using my string sub function to subset just the very first letter of that name column. Then I'm grouping by that first name, counting and arranging in descending order. So those are the steps that I take, right? I know I need to subset. I know I need to get down to just one letter. I need to group all those letters together, take a count, and then arrange. And so here, when I look at first letter, I see that A has by far the most count with 210,042. And then let's see, who has the least? X, not surprising. X only has 3,521 names that start with X. So that's it with string. Our next video will be on joins.